Hello friends, this is Rupesh and watching CBPNet's video series on sorting algorithms, and in this video we'll be looking into this merge sort algorithm. Okay, so these are the topics we'll be covering: the introduction part, an example with a good diagram, and third is program understanding with recursion, okay, and the theory part. Okay, so let's start with the introduction to the merge sort. Merge sort is a divide and conquer algorithm. Everyone says that, but what is the meaning of that? So let's start with this small example like 5, 1, 3, 2 and 4. So let's suppose this is your array elements, okay, and these are the indexes, and you want to sort this array. So what you will do in merge sort, you will divide this array by 2, okay, so ARR by 2. So as this is odd number of elements collection, either of the side will have one greater element, okay. So if you are dividing this, then it would look like this: 5, 1 and 3, and next half would look like 2 and 4, okay. So this is your one array and this is your another array, okay. So that's why it is called divide and conquer. You will be dividing your bigger problem, which is this problem, into smaller sub problems, and you will be solving smaller problems, and ultimately the bigger problem will get solved, okay. So this is the whole idea. So that's why we are dividing it. So we will divide this array, which is this original array, until unless we are having a single element in each and every array, okay. So if you will divide this further, then this is also odd number of elements in the array, so somewhere it would be like 5 and 1, and here only 3, okay. So let's divide this as well. So this is 2 and 4, like this, okay. This is one array, this is one array, this is single element, this is single element, this is single element, but this is still double element, so we'll divide it further, okay. Then 5 and 1, okay. So now we can see each and every element is single element. Now what you will do, you will merge these two elements, okay. You will start merging. So from here to here it was a divide operation, okay. Now from here onwards it will be a merging operation, okay. So we'll see how it will work. The idea is you will take two elements and merge it by sorting them, okay. So 1 should come first and 5 should come later, okay. Now you will merge this array with 3, so it would ultimately look like 1, 3 and 5, okay. Now you will merge 2 and 4, then it will be like 2 and 4 because they are already in sorted form. Now you will merge these two, okay. Then it will be looking like 1, 2, 3, 4, 5. We know that, but how it will look 1, 2, 3, 4, 5? What is the merging process? Let's understand with this example. When you are going to merge two arrays like this one and this one, you will be setting the pointer, like let's call this one I pointer and this one a j pointer, okay. So initially both will be pointing to the starting location of the array, and we will compare that 2 and 1, which is less, 1 is less, okay. So this will go inside new array, okay, here, and once this has moved you will increment the j, so j will come here now, okay, and you will again compare jth location with ith location. You have not incremented this I here, okay, I is still pointing to this location. Then you will be comparing 2 with 3, which is less, 2 is less, so 2 will come here and this 2 will go, and once it has gone I will get incremented. Now I is pointing to this one and j is still pointed to this one, so you will compare 3 with 4, so which is less? This time 3 is less, so 3 will come here, okay. As this has gone, you will increment the j. Now j is pointing to this one, so again do the same thing, compare 5 with 4, which is less, this one. So this will go here. Okay, I will try to go forward, but there is no element, so we will stop here. Now notice one thing, this 5 is still left. Okay, so whatever the leftovers are, we will just simply copy them. Okay, so 5 will come here. Not only 5, let's suppose there are so many elements left over, you will copy all those elements as it is. Okay, so ultimately you will be getting a sorted array. Okay, so that's how you did it. Like, you divided it from here to here. Okay, until unless each and every element is broken into single array elements. Okay, so this one, this one, this one, this one, and this one all became single. Now you started merging. Okay, so this we do in recursive process. I have already said that in program. So understanding program will give better understanding of this whole scenario. Okay, so let's look at the program now. So this is the program here. We have this main function and created an array. Calculate the size of the array, which is 5 stored inside n, calling this merge sort function, and after coming from here we are just simply printing that. Okay, so as you can see, 5 1 3 4 2 is the input. If I will compile this, output would be 1 2 3 4 5. So this is a working code. We will see how it works. So this is your main function you are calling here. This is that function. We are not doing anything fancy in this. We are just simply calling a utility function, which is this one. Okay, we just pass all the elements how we get from here into this function. Okay, if you want, you can remove this function, you can directly call this, but I prefer this way. Okay, so ultimately you will be dealing with two functions. First is this one, this merge function, and second one is break it function. So let's try to understand how this will work. So this is your program here, and let's write something like 5 1 3 2 and 4, and we'll understand this program with the help of this array. Okay, so initially here this function is getting called, break it. So you remember we were breaking it and then we were merging it. So two breaks are there, like break it and break it. We'll see how this whole thing will work. Okay, so this is kind of recursive call, and when you will break it, after that you will merge it. Okay, so this is the function for merging. So this is the logic for merging. Okay, so whatever I explained, like how iteratively it will merge, this is whole thing here. Okay, so let's assume your array, which is this one, is passed here. L will be 0 and R will be 4. Okay, so let's not write here, we can just simply write here. This is your L, this is your R. Now as I told, we will be dividing it into half. So we will calculate the length like this, L plus R minus L divided by 2. Why we are using this equation? Because it should not go overflow. Okay, because if you are doing it like L plus R divided by 2, that will also give you the half. But let's suppose this L is the maximum value inside integer. Okay, what the integer can hold, and I am using integer here to catch it. This L is integer, and if you do increment, then the integer data type will overflow, and whatever the value you will get after dividing, that won't be the half of this. Okay, so that's the reason we are doing this, L plus R minus L. So this will not overflow. Okay, so let's remove this one. Yeah, so we came inside. The condition is L is equal to R. This is called a terminating condition. Okay, your recursion should always terminate. That's why this condition is always kept. Okay, because you're calling yourself again and again. See, break it and break it. So we have divided ourselves, and whatever we get is the middle one, M. M is used for middle one. So middle one will be 2, because R is 4. So if you will calculate this, you will get it 2. So you are calling yourself, which is like break it with the same array with 0, L is 0 for now. Okay, this is 0th location, this is first location, second location, third location, and fourth location. Okay, so for now I'll just remove this. So 0 and 2 will be passed in itself. Okay, I mean it will call itself. Now L will be 0 and R will be 2. Before R was 4. Okay, so let's draw it like this: 5, 1 and 3. Okay, and we will have to maintain M also. So this was your array. Here L was at 0th location, this is 0th location, this is 4th location, but M was 2 here. Okay, so you call yourself and L is this one, R is this one after calling yourself. Okay, and here this is one array and M is equal to 1. Okay, why? See, you will come here, L is 0, R is 2, L is equal to R. No, it is not true. You will come inside, you will do this calculation. In that case you will get 2 divided by 2, which is 1. Okay, so you will call again this function. Okay, so this time L is 0 again and M is 1. Okay, so this will be like this: 5 and 1. This has become one array. L is this, R is this, and here M is 0. Okay, so you came inside. Why M is 0? Because you call yourself with 0 and 1 this time. Okay, so if you will come inside this, L is equal to R. No, it is not. Then you will come here, then R is 1. 1 minus 0 will always be 1. 1 divided by 2, it will be 0.5, but it is integer, so it will become 0. So that's why this M is 0. Okay, so now you will again call yourself on this array. So L is again 0th position, you can see here, and M is also 0. So you will call with 5. Okay, so this is your element, and L and R both are same element. Okay, so as you called, both are 0. This is also 0 and this is also 0. Now you will come inside. L is equal to R. Yes, because both are 0. So you will go back. So once you are coming back, you will come to this statement. Okay, because you went to this function because of this statement. So when you will come back, you will come to this statement. Okay, this is how this recursion works. So this statement is completed now. Okay, this one. Now you will execute the next statement, this statement. So what was the value of all the variables at that time? This one. Okay, L was 0, R was 1, M was 0. Now you are calling the same function but with second half. What do I mean by second half? See, it is like this is the first half and this is for second half, this statement, because let's suppose this is your array 1, 2, 3 and 4 and 5. If you will calculate this, middle is, let's suppose, this one, then from L to M will be this one. So second half will be M plus 1 and R. Okay, so this is your M plus 1 and this is R. So that's why this is M plus 1 and R. So second half is considered like M plus 1 and R. Okay, so you went back from here to here. Now these are the values status, and you are going to call yourself again but with right hand side. So with 1, and how you will call? See, M was 0. See, M was 0 and R was 1. So M plus 1, which will become 1, and R was also 1 here. Okay, this is position 1. So in that case, both are 1 and we are passing 1. So instead of this 0, 0, let me remove this. This time we are having 1 and 1. So it will be like this. This is your array element. Left and right both are equal. So if both are equal, we will go back. Go back means go back here. Okay, so now we are back means we again came to this statement because we called ourselves from here. Now you went inside and you checked L is equal to R. Yes, it is true. So you got returned. Returned means you will be coming back to this statement. After that you will execute merge it. Okay. So see, here you are calling merge it. Okay. In that case, you are going to merge 5 and 1. Okay. And we'll see how we'll merge that. So we are passing to this function. Okay. Merge it. And we are passing the same array L, M and R. So the values are like this. L is 0 here. Okay. Because we are standing at this location. So L was here and R is this. So R is 1. M is also 0. Okay. So let's put it 0. So it will be easier for us to track. Okay. So this is 0, this is 0, this is 1. Okay. So this is just a simple variable declaration. Now what you will do, you will create two arrays. Okay. So we are just simply calculating the size of left side array and right side array. Okay. So this is the calculation for left array size M minus L plus 1 and right hand side array size would be R minus 1. Okay. So both will result into one size. See, M is 0, L is 0 plus 1. So ultimately you will be having 1. So left array size is also 1 and R minus M. R is 1. So 1 minus 0, 1. So both are one size. So you can see both are 1. Okay. So as you have calculated the size, you will create the arrays also. Okay. So this is left array. This is right array. Okay. I have given this whole example in very compact form so that everything will be looking at your screen and you can visualize the working of this algorithm. Okay. So this was like you created two array. Okay. So where to create that? Let's suppose you are creating it here. Okay. No, here like 5. No, initially it will be empty. So one element, another element. This is right and this is left. Now you will fill these arrays. Okay. So fill left and right array. See, I have given the comment also. Okay. So this first 4 is to fill the left array. So we'll just keep on filling and this is the formula for filling. Okay. And this one is for right hand side filling. So left is you filled it with 5 and 1. Okay. So this is also over. And remember this is an extra array space. We will talk about this extra space in theory. So don't forget this. Okay. There is a big impact on creating this extra space. So this was over. Now I is equal to 0, j is equal to 0, k is equal to L. This is important actually. Now read out this. Compare left and right array elements and whichever is holding smaller value, put that inside main array. Main array is this one. This is left hand side temporary array, right hand side temporary array, but this array is our main array. Got it? So we will compare element by element. I told you in my previous explanation that how you will iteratively compare both arrays and merge them. Okay. So remember that technique. We'll use it here. So while I is less than left array size and j is less than right array size, these are the pointers I was talking about. Remember? Now, if left of I is less than right of j, means left hand side is the smaller one, then we will initialize left side inside our array. Okay. So let's see how it is working. Your left is 5, right is 1. So see, left of I is 0 and j is 0. So this is also 0th position and this is also 0th position. Okay. This is I, this is j. I will be explaining it bit by bit because lots of people give up on these algorithms because they don't really understand and they suffer a lot in future. Okay. Because I have suffered, so that's why I'm spreading whole knowledge so that no one will suffer if they can reach to this video. Okay. So coming back to the point now, we were talking about this. Left 0 position, right 0 position. No, this is not true. This condition is not true. Your right hand side is smaller. So you will not go inside this one, you will go inside else, and else is this one. Okay, so you will initialize right hand side inside array. Okay, so your array, which is this whole array, would look like this, because k is L and L is 0. So I have updated 0th position. Don't think that where is that 5. 5 is still here. Don't worry about that. Okay. Then k plus plus. So k was 0. K will become 1 now. Okay. So it will be pointing to this one. I am not drawing anything because it will be very messy. So you will go back here, and yeah, j was also incremented. So this condition will be false now. J is 1 and right array size is also 1. Okay. Remember, this was 1. So this while loop will break. Okay. So as I told, after merging, you will be copying the leftovers. Okay. So this is the procedure for copying the leftovers. So this is the command. We can just simply read that. After comparing both left and right array elements by elements, if some element, array element is having left over, then just copy that array into main array. This is something wrong. Okay. Anyways, so this first while loop is for copying the left array. So it will be checking like I is less than left array size. See, remember, you didn't change I, you changed j. Because of j only this loop was break. Okay, not I. So in this case, this while loop will be running and it will go inside array of k. K was 1. Remember, k was incremented. Now 1 will be initialized with left of I. I is 0. So this 1. So k is 1. So we will initialize 5 here. Okay. So 1 and 5. And after that, it will come again and it will check. After I will get incremented, it will see that okay, I has become 1. 1 less than 1. No, it is not true. It will be coming out from this loop. It will check this one, but this is false, so it will not go. We will hit this terminating bracket. We will come out from this function back to our break it function. Okay, it means we will come here, but these elements are looking like this in our array. So let's change them. This is 1. Let me change it properly. Okay, so now 1 and 5. So this whole thing is done. So we will go back from here. Okay, so from here to here, we came here because of this break it. Okay, now we'll go back. So once we are going back, what are the values? That's why I'm writing all these things. M is equal to 1. So this M was 1 and L was at 0th location, R was at second location. So as you are coming back from here, you will be going to this statement. Okay, this one. So you already saw that you handle these two elements. Now you will be handling this one. Okay, so break it will call M plus 1. M was 1, so it will call M plus 1 2. R was already 2 here. Okay, so 2 and 2. You will call yourself like this. 3 and L and R both will be equal. Okay, 2 and 2. So after calling, you will come here. L is equal to R. Yes, it is, because both are 2. Okay, so you will get this return statement executed. You will go back. So you will come again here. Okay, so you are going back from here to here. So before you came back from here to here, now you are coming back from here to here. Now see, what is the situation for this merge? L is still 0, M is 1 and R is 2. Okay, maybe I should use some little darker color to denote that. Maybe it is okay. Okay, we can just simply update here, no problem. I know I'm taking a little longer time, but it's okay. We can bear it because this is merge short, right? It will obviously take time. And 0, 1 and 2. So this will be like 0, 1 and 2. Will come inside again. Left array size will be calculated. M minus L 1 minus 0 plus 1. So left array size will be 2. See, this is 2. And excuse me, I should have changed this also, because this is nothing but this original array only. Okay, so this is 1 and this is 5. This has changed here, it means it has changed here and here, because all are pointing to the same array. I'm just demonstrating with different T hierarchy. Okay, so this has become 2, and right hand side array will be r minus m. So 2 minus 1, it will be 1. So this is 2 and this is 1. Okay, so again the same procedure, you will create left array, right array. This time your left array would look like this, L, and right array would look like this. You forget about this one. Okay, now L will be like 1 and 5, right hand side will be 3. Okay, so this was for filling the arrays. We have already filled it, and then after filling you will come here and compare it. So this was the original merging process. Okay, so left array size is 2 and right array size is 1. I is 0, j is 0, k is L, L is 0. Okay, so initially this condition is true. We'll go inside. Left of 0 is less than equal to right of 0. Is this one less than this one? Yes. Then what you will do, you will update k. Don't forget k is 0. So you will initialize 1 here. So ultimately there is no change. 1 is already here only. Okay, so no need to think like why it is overriding. This is the way it works. Okay, so 1 has gone from here to here, the original array. This is ARR. Don't mess up. This is the temporary array, left and right, what we are creating here. This left and this right. So after this assignment, you will increment I. So before I was here, now I will come here, and j is still here. So after assigning this, k will get incremented by 1. So k will become 1 now. So let's write it here. K is 1. You will hit this while again. I has got incremented. So I has become 1 now. Okay, 1 is less than left array size, which is 2. Yes, it is true. And j is still 0 and right hand size is 1. So this is okay. We'll come inside again. So we'll check left of I, which is 1, less than equal to right of j, which is 0. So ultimately you are comparing this one and this one. So this condition is not true. So we'll go inside else and we will initialize right, which is this one, to this place. Okay, so let's write that. This was 1 and this is 3. Okay, after doing this, you incremented j. J has become 1 now. Okay, so k will become 2. You will go back. I is okay, but this j is 1 and right hand side array is also 1. So this condition will be false. We will come out from this loop. Okay, so this has gone replaced, this has got replaced, but this is still lying. Okay, so this is left over. Okay, so we need to push this. So this is for that. While loop, I left array size. Yes, it is true. I is 1 and left array size is 2. So this is where the leftovers are. So it will go inside. So whatever the leftovers are, it will push inside the original array and keep on incrementing I and j. Okay, with the help of that, you can just simply push all the left array elements inside here. Okay, so k was 2. So this is second position. You will push 5 here. Okay, so I is 1 and this is 5. So 5 will go here. Okay, 5. So ultimately this is changed. Okay, so let me change this also. 1, 3 and 5. So once you are done with this whole thing, you will go back. So from here you will go back here. Okay, and this is the original array status right now. Your m is 2, L is pointing at 0th location, which is this one, R is at 4th position, which is this one. Let me write the index 0, 1, 2, 3 and 4. Okay, so this is your index part. I should have written this long back. No problem. So you went to this whole stuff because of this call. Okay, first time you came into this break it function from merge sort function, what I showed before, that time your status was this. As soon as you enter here, you called break it, first time you went here, you came again, you call yourself, you went here and all that. So now you are returning to the main. Now you will be calling this statement. Okay, so I have all the values like L is 0, R is 4 and M is 2. So let's see how this whole will be working. M is 2, so 2 plus 1 3 and R is 4. So second half will be broken. See, we are calling 3 and 4. So here it will be 3 and 4. Let me just remove this. 3 and 4. See, this is third position and this is fourth position. So we have already sorted this one. So we are going to break this one iteratively and sort this. Okay. So 3 and 4 are going to get divided. So let me clear this mess. Okay. So this would look like this. 2, 4. Okay. And L is this one, R is this one. Let me calculate the M here. M will be 4 minus 3, which is 1. 1 divided by 2 is 0 and it will be L. So L is 3. So M will be 3. Okay. L is, we can see here 3 and R is 4. Let me write that. 3 and 4. This is index. Okay. Don't mess it. Now you will check this L and R. No, they are not equal. You will go inside this. So that's why this M was updated like 3 and you will call this function now. I mean this statement. Okay. So L is 3, M is 3. So third one is this one. So this will come here. 2. L and R both are equal. This is be called and this will be like L and R both are equal. Okay. I'm going a little fast forward because we know this process, right? We have understood here. If you forgot, please rewind the video and see this again, this process again. Okay. So you will call yourself. So 2 will come here and 4 will come here. As both are single element, then L and R will be pointing to the same location. You will go back from here and here. So once you will come back from here and here, you will call merge function. Okay. So when you will merge, I'm not going through this again. When you will merge it, 2 and 4 are already in the sorted form. So nothing will change here. You will just simply go back. Okay. I'm just doing little fast forward because this video is going to become very long otherwise. Okay. If you have any doubt, you can ask in comment. No problem. So once you have come here, so if you are standing at here by coming back from this side and this side, it means you are pointing to the first stack in your program when you reach to this function. Okay. So you reach to this function, that time your whole array was this one, your L was 0, R was 4. Okay. And M was calculated as 2. You went here because of your first call to this one. Now you are back from here and you went here because of your second call from here. Okay. So now you are back from here also. So now you will call merge it. Okay. And the values will be these values, like L will be 0, R will be 4 and M will be 2. So let me update that. L is 0, M is 2, R is 4. Okay. So here also L will be 0 only, M is 2 and R will be 4. Okay. So the same thing, you will create dummy arrays like left and right. In this case, left will be your this one and right will be this one. Okay. And you will copy your left and right. I mean, you will fill that left and right. So ultimately it will be filled like this. 1, 3, 5. Right hand side will be like 2 and 4. So this is over now. Now you will come inside here and you will compare element by element from here and here. So first you will compare this one with this one. So this is lesser. So this will go inside your original element. Let's suppose this is the original. One will come here and you will increment that pointer. Now you will be comparing this one with this one. So 2 will come here. Okay. So you will increment this pointer now. So you will compare 4 with again 3 because this pointer is still here. So 3 will come here. Okay. So as 3 has come from this array, you will increment the pointer. Now you will compare this one with 4. So 4 will come here. Okay. This is happening in this whole while loop. Okay. I'm not going to explain this again. Now as this has come here, you will try to increment this pointer, right hand side pointer. Okay. Then you will realize that no, I'm going out of boundary because of this condition, and this while loop will break. Now we are going to copy the leftovers, and the leftover is this one. So left hand side is pointing to this location, which is second location, and left array size is third. So 3 and 2. 2 is less than 3, that is okay. So you will copy the last 5 here. Okay. And after doing this, you will not go inside this while loop, you will go back. So once you have hit this one, you will go back to the original function from where did you call this first time, and that is this function, merge. Okay. So you will come here. So this is done. So you will go back and you will just simply print this. So let's print this. See, 1, 2, 3, 4, 5. This is a working code, and I really enjoyed this video. Okay. So coding part is done. Let's look at the theory part. So these are the points I wanted to discuss, first, second and third. I won't go into so much of detail because this video has become really very big. Maybe I'll go for some analysis of merge sort video in future. Okay. So for now, just note it down that time complexity of this algorithm in best case, average case and worst case is order of, big of n log n. Okay. And is this algorithm a stable algorithm? If you don't know what is stable algorithm, stable means if your element is like this, 5, 2, 3, 2, 1. So you can see if you will sort this element, the array, it would look like 1, 2, 2, 3, 5. Okay. But this 2 is already at this location, and the stability concept tells that if this 2 is at correct position, then this 2 only should be at the final position. Okay. We should not mistakenly place this 2 here. Okay. And this 2 here. No. Then this algorithm will not be stable. Okay. But this is a stable algorithm. Merge sort is a stable algorithm. Why? Because if this 2 is at its correct position, then the same 2 will come here. Now you will ask why, what is the difference between these two? So we will not go much into detail because we don't have time. So this is stable. The answer is yes. Is it an in place algorithm? Yes, it is in place, but in some sense, but you use extra array. So sometimes we don't consider it in place algorithm. So for this I will say no. Okay. Because you remember we were taking left and right arrays, and those arrays were filled, and we were comparing those arrays and checking and filling the original array. Okay. So because of that only, this algorithm is not in place algorithm. Okay. You can expect a more detailed theory analysis in future coming videos. So for now, this is what I can offer. Okay. So thanks for watching. Bye bye.